Hello team, this is going to talk about serverless computing. And this is kind of a misnomer because there are definitely servers involved, so it might also be called a function as a service, which is a little bit better. So let's go back to our example of the to-do list application. So here we want to have a to-do list application that will handle requests from a client. And the functions we discussed before are related to adding, getting, editing, completing, and deleting to-dos, and also managing all of the to-dos that we have. So what we want to implement really in our application are these functions. This is what we want our application to do. So it would be great if we could just write these functions, add to do, get to do, complete to do, delete to do, and so on. And this is what serverless computing allows us to do. So we just write code for our functions, and I have this lambda over here just to denote that this is a function that we're going to run. So we just write our functions, and that's it. So to get the application to work, we also need something to redirect the client requests to our functions. So we might also write another function that's just called API redirect. It's going to get the requests, see which function it's intended for, and then call the appropriate function. And we might also connect our functions to a database service, not a database service. So this database service accepts requests for modifications to the database from these functions, but it's not operated by the developer of the to-do list application. It's operated by the cloud providers. So this is why it's in blue. So it's not something that we built, it's a service provided by the cloud, and we're going to use it in our application. So whenever we need to store something in the database, we're going to send a request to the database service, and then it will store this information for us. And when we need to retrieve some information, say a to-do that someone has created before, we're going to access the database and retrieve this information. So it's great to have the cloud provider manage a service for us, like this database service. And because this API redirection function might be common to many applications that have different functions, you might imagine that the cloud provider might also have a service for redirecting requests. So we can also have this function be managed by the cloud provider. So in this case, we have API redirection managed by the cloud provider, we have the database service managed by the cloud provider, and the only thing we implemented was our functions again. So this is what we wanted in the beginning. So there's no Nginx, no Django, no containers, no nothing. We just implemented our functions. So this is great if we're considering, for example, how fast we can deploy an application. All right, but how does this work? So it's not magic. One important thing that's behind serverless computing is a runtime that's managed by the cloud provider. So the runtime is in charge of running our function. It calls a function whenever it receives an event. So the runtime has monitoring and facilities required for orchestration. So scaling in and scaling out, it's all built into the runtime. The runtime reads messages and events or calls to our functions, and it forwards the calls to our functions. And when our functions return, the runtime takes the return value of a function and sends it to the database or sends it back to the client. So the runtime takes care of gluing our function with the rest of the world. Now this runtime imposes constraints on the functions because we can't run any function inside the runtime. So in Amazon's AWS Lambda, for example, we have native runtimes for Java, Go, PowerShell, Node.js, C#, Python, and Ruby. And if you want to use a different language, then you have to interact more closely with the runtime. So it's not as straightforward. So the runtime imposes some constraints on how we can implement our functions and what they can do. Another important aspect of serverless computing is that the functions we write, they are event-driven and stateless. So let's remove the client from the picture so that it can get more space. So one thing that I mentioned here is that the functions we write are event-driven. So we have event queues for each of these functions. So whenever a request arrives, it enters this queue, and then it will be serviced by one instance from one of the functions that we are running. So if a function receives many requests, if its queue starts to grow, then the cloud provider can spawn new instances of our function to take care of the increase in load. But the important thing is that the functions, they communicate with one another with message passing, and we have these channels that store the events before the function has the opportunity to take the event out of the queue and start processing it. Another important property is that these functions we write, they must be stateless. They can't have any state in memory because the cloud provider might decide to shut down our functions any point in time. For example, let's say no one is deleting their to-dos. Everyone is marking their to-dos as completed or editing them. And the deletion function is very seldom called. So what might happen is that this function might not have any requests on its queue. So the cloud provider might just shut down this function. So it's not even running anymore. It's using 0 resources. And we shut this function down. So if we had any state in memory, that state would be lost. So we can't store anything in memory. So this is why we say that the functions must be stateless. We must allow our functions to be shut down at any point in time. So all state must be stored in the database service. So whenever you need to store something that you might need in the future, you send it to the database, and then whenever you need it, you retrieve it from the database because the function might be shut down at any point in time. So what happens when the function is shut down and a request arrives for it? So in that case, let's say a request arrives to delete a to-do, but the to-do function is shut down. So the API redirect will place the event on this queue for the delete function, and then the cloud provider will spin up, will start the runtime for this function, and then the function will process the event on the queue, and then it might be shut down again. But there's this additional delay in starting the function so that it can process the event that just arrived. Okay, so let's summarize. So what are some properties of serverless computing? So one big win is that developers can focus on their application business logic. So they can focus directly on the functions that their application wants to perform. There's also significantly reduced management complexity. So the developers don't need to create containers, don't need to worry with virtual machines. The orchestration for serverless computing is built in. It comes built into the runtime, and the cloud provider has all the management infrastructure around it. So auto-scaling, for example, is automatic. And we can avoid configuring databases by relying on database services provided by the cloud. And like we said, the serverless computing paradigm has built-in scalability. If a function is shut down, if it doesn't have many requests, then the costs we pay might actually be 0. This is called scale to 0. So if a function is not using any resources, you don't pay anything. And if a function doesn't get any events, then it's shut down and doesn't use any resources. So you can actually pay 0. And we also can scale to infinity because whenever requests start to arrive, they might pile up in the event queue. And if the cloud provider sees that the event queue is growing very large, it can spawn new instances from our function. And then the function will take events from the queue. And then we can keep balancing the number of functions that are running and the arrival rate of events on the queue. And what are some disadvantages of serverless computing? So one limitation is that the runtime limits us. So for example, it can limit the languages that we can use natively, or it can limit the amount of RAM that our functions can use. For example, if we want to do some very heavy scientific computation with serverless computing, then the runtime might not allow us because it has a limit on the amount of RAM that the function can use, for example. If a function is shut down and needs to be started up to service an event, then we will incur an additional delay. This startup delay will delay a little bit the response from that function. And although this delay is small, it might be impactful for delay-sensitive applications. So delay-sensitive applications might not be a very good fit for serverless computing. Another problem is harder debugging because the environment that our functions run in is closed and proprietary. So we might not have very good introspection solutions like debuggers to understand what bugs we have and fix them. And finally, and this may be a big issue, is that serverless computing relies on these runtimes that are proprietary and come from specific cloud providers. So if you build your function for a specific solution, say AWS Lambda, you might need to change a function if you want to later move to Google or Alibaba Cloud. And if you're using the solution for building functions, you might also be using the solutions for the API redirect and the database. So if you want to move your functions out of the cloud, you might need to rewrite many different integrations with services from the cloud that you were using before.